Okay, so welcome to this fifth video for week 1. So as I indicated to you that every week I'll make 5 videos on average. Maybe some week we may have only 4. We'll see how it goes. This is the last video for this week, and then again I'll but we'll have our regular classes scheduled. So we'll discuss this in more detail over there as well. So if you this issues that we are talking about in terms of impact, because all the different activities that we are doing is leading to certain impact, and that impact is essentially we are talking about the environmental impact. So if you this impact is if you are looking at any industrial ecology book, which is looking at the impact from different industrial activities on environment, we call it an IPAT equation, as because of the 4 terms that is used: I, P, A and T, which I is for impact, P is for population, E is for affluence, and T is for technology. Now, we calculate impact by looking at in terms of population, in terms of affluence, and also in terms of the technology. Now, how to reduce this impact? Ultimately, the goal, as you saw, that we are increasing our ecological footprint. We are already in ecological debt. From 80s onwards, we are using up more resources than what is Mother Earth can provide to us on a yearly basis. So we have to start reducing the impact so that we can reduce this our ecological debt. So to lower impact, since the population, you saw already the data that population is going up. It will go up even in recent decades. We'll see the increase in population. There is no other option there. So population will go up. Affluence is related to GDP. Now, if you have more GDP, people are getting more affluent. They can have more disposable income, so they will buy a lot of different kind of stuff. And you need that for your GDP to go up, to create jobs and other stuff. Although we are already discussing about how to produce different kind of jobs, so that you don't have to always say produce. For example, say when you go, you might be having a laptop, or so if you look at a laptop charger, the charger, the point which goes for the charging point, sometime if you look at them carefully, older ones may have a circle, then it becomes a hexagon, sometimes rectangle, sometimes some different shapes, sometimes again circle, but with a pin on top of that. So and most of the times that charger it doesn't need to be replaced. We can use the new laptop with the old charger too. With maybe certain modification, but we are forced to buy this charger because we have to produce more jobs. That's how the GDP goes up. But that's a different debate. We'll have it on some other day in this particular course. But in general, as more GDP, more people affluent, so as the affluent goes up, you will see more impact, which is kind of well-known fact. So what is left here? In this IPAT equation, population is going to go up, affluence is going to go up, but I want I to be down. I want the I to be less, impact to be less. So population and affluence both is going up. So only thing left is technology. So I have to bring that impact of technology down. Now that is how we can do it, by producing green. So we have to produce green. Affluences go up, so we can do some sort of lower consumption. That is again another thing we can possibly do, lowering the consumption, but that has an impact on the GDP that will lead to maybe loss of jobs and other stuff. So we have to be really careful about that. But as an engineer, we have to produce greener technology. We have to have greener technology in there. So in terms of this aspect, in terms of lowering of consumption and all, we'll talk about more in detail later. Don't get me wrong. Then when I do think I'm not promoting more and more consumerism, but what I'm saying is we need to look at it more carefully in terms to have a balanced growth. So how will you see the IPAT equation with expanded set of inputs through a causal loop diagram? So you have a population, you have impact, your affluence, and then you also have like pollutant, which is the technology point of view. So, you need to have gender equity, literacy, art, your birth age, ethics, spirituality, policy, non-sustainable development, then you have a sustainable development. So, all these different factors will come into when we talk about these 3-4 parameters right there. So, population is related to the birth rate is also related to the gender equity, but it is also related to ethics, it is also related to literacy. And then when you talk about policy, that kind of relates to like how much is the consumption pattern. Spirituality also can lead to some of the consumption pattern. Then in terms of environmental degradation, environmental impact, that remains to what kind of technology we use, what kind of policy we implement. So, these are all related together. So, it is a pretty complex issue. So, there is a disease, it is not influenza, it is affluenza. It is how overconsumption is killing us and how to fight it back. So, this is this is just a kind of it is a third mutation. Its affluenza is an unsustainable addiction to overconsumption and materialism. It is exhibited in the lifestyle of affluent consumers in the United States and other developed countries. It is usually described as an endorsement of the flow of wealth that causes a division of classes, loss of financial, environmental and emotional balance. It is an important reason for environmental change, a scarcity of biodiversity and the heritage of living offspring. So, this affluenza problem, it's to some extent it is even sometimes it might be a bigger problem, and then your other issues that is out there. So, we have to think about like how to reduce the consumption and how to reduce all the waste produced with the consumption as well. Because first we buy and bring all these resources, then we use it and just dump it into the environment, creates the waste management problem, and then that's waste degradation in the environment leading to land, soil, water. You have your air pollution, water pollution, soil pollution, all those different issues associated with that as well. So, is the dramatic rise in per capita consumption it has serious environmental consequences. So, it's a rising per capita consumption leads to more resource extraction, leads to loss of biodiversity, more fossil fuel use, global climate change, economic loss, health impact, social, more waste, and then we talked about this issue of this affluenza disease. Then what is the causes? Like we with the rising per capita, we go for more. We have to look for newer technologies, which is more agricultural production, more resource extraction, more manufacturing. All idea that all growth is good. Advertising also forces you to consume more. Globalization and trade, that also kind of forces you to consume more. So, we need a healthy lifestyle for sure, we need a balanced lifestyle for sure, but many times we also have to think about that all the different resources that we are consuming on day to day basis because of this so called affluenza problem, is it really worth it in the long term? So, what is the overall impact into the environment from overconsumption of resources? And overconsumption of resources leading to a lot of environmental degradation. So, is it should we go for that? So, it kind of goes into some of this philosophy and other issues. Some of our HSS friends who are there in the class later on probably will be taking some of those issues further. So, this is again from an engineer point of view, from a science point of view, again we have several issues out there in terms of how to reduce the fossil fuel usage, how to increase our efficiency of the process, how to reduce the waste and pollution, how to design the product. Say we have here we have different engineering groups in the class. So, how to design your product so that it's easy to recycle. When you make a new product out there, how to design it. When you make a new label for, you look at all those different fancy products which gets advertised on the TV, different, say even as simple as a juice. The juice bottle, the cover of the juice bottle, the plastic layer on the juice bottle, how to design it in such a way so that once the people drink the juice and put it in the dustbin, it is easy to recycle that material. It is easy to recycle that product. So, those things we need to look at. because see, there are based on present scenario, reduction in consumption, as the per capita GDP goes up, we see more and more consumption, and we will see more and more waste produced. Of course, our goal is to reduce the waste production, but that does not happen overnight. So what we need is to come up with a better way of managing these different issues, so that at least in the short term, in the medium term, we are having less environmental problem. Now, if you look at the human impact on environmental system, we have three big criteria like biogeophysical system, we have biodiversity and natural resources. They have complex and interacting components. So, physical system is your atmosphere climate, biogeochemical cycle, you may have nitrogen, carbon, phosphorus and iron cycle. Biodiversity, these are the factors we like mass extinction, biodiversity loss, invasive species. Natural resources, of course, water, minerals, fossil fuel, land productivity, pollution and all that. So, if you look at the localized impact, again looking at this impact as a population times affluence times technology, that IPAT equation, initially in the pre-common era, in the very old times, we were looking at mostly some people were not moving that much. Most of the people will be born in certain area and probably will die in that area itself. So, global population was also quite small and growing to around 200 million. We saw some impact. The blue line shows that some impact, the red shows some like a more severe impact in terms of some mass extinction, but we saw some impact in biogeochemical cycle, biodiversity loss and all that, and also impact on water, minerals and land productivity. Then we became more of if you look at in 1800s onwards, things are becoming global impact. People started moving around a little bit. So, you started seeing more, and things are becoming more from blue to red now. We start all these things got impacted, and then even in fact a lot of impact here as well. So, global population growing exponentially to around 8 billion. So, we are seeing impact to pretty much every sector which is out there. So, that was global kind of a global scenario, but even in Indian scenario, if you look at, we are becoming more and more urban. This is 2001 census and this is 2011 census. Next census will be in 2021, isn't it? Because of this COVID pandemic, maybe it may be slightly delayed, but I don't know actually for sure. I have not tried to find out whether it will be in 2021 or it will be delayed. But if you look at here, and here as the color changes, here the yellow color is the list yellow, then after yellow we have green, and then which is like yellow is your yellow is the like a rural, then we have the green, then we have the blue, then we have purple. So, as you go down from yellow to green to blue to purple, it is becoming more and more urban. So, you see that in 2001 many of those states were in like in yellow color, where you saw that more and more like rural area. Then and quite a lot of states were in green color as well. So, little bit of urbanization in there, but from 2001 to 2011, many states moved from green to blue, becoming more and urban. For example, in West Bengal, where we are like I am right now, it moved from green to blue. So, it is more urbanized now, and some states like for example, in Maharashtra or in say Tamil Nadu and Kerala, Tamil Nadu moved from blue to purple, Kerala even moved from green to purple. So, huge urbanization there. So, so there is a change, and 2021 will see further changes as well. So, this is becoming more and more urban, and then all the urban issues that we discussed is also relevant for the Indian context. So, based on different things that we do globally, we consume around 50 kg per person per day of resources, and out of that only 3 kg gets recycled and 21 is in use. So, 21 plus 3 is 24, rest around 26 kg of resources is just going dumped into the environment. We cannot have that business as usual, and that is leading to a lot of increase in our ecological footprint. Now, ecological footprint means the amount of land area and water required to produce sustainability, the resources or ecological services needed to support a defined population at a set standard of living. For example, Vancouver has a population of 1.7 million. Vancouver is in Canada, and if you look at the ecological footprint of Vancouver, it is 19 times its area. So you need actually 19 times of Vancouver to produce all the resources that is needed to support the population of 1.7 million people in Vancouver. So that's not a sustainable lifestyle. So we have to have a better lifestyle there. Netherlands 14 times its area. Australia has one of the highest footprint of 6.25 hectares per person. And of course, in Australia they have the issues of mining and other stuff, which again, and this leads to a lot of ecological footprint there. So ecological footprint calculation has when you look at the ecological footprint, you look at the biological, you look at the energy, you look at the built up footprint, biological resource manufacturing, and energy production. So it's how much biological resource manufacturing footprint minus net export trade. So we'll again in the class we'll talk about it more in detail. So this is there are certain ways you can calculate ecological footprint. Ecological footprint, when you look at the ecological footprint, we look at the forest products, carbon, cropland, pasture, build land and fisheries, all those different aspects which goes there in terms of the ecological footprint calculation. So there are some in terms of energy settlement, we have timber and paper, food and fibers, seafood, fisheries, cropland, forest, built up land, carbon footprint calculation. So when we talk about ecological footprint, essentially it's kind of trying to get the combination of all these together. So that's what it's all about. It's trying to get the total ecological footprint in there. So if you look at again which we were talking about earlier, that if you have one planet, the one planet limit, we have only one planet. So if one planet limit by around this is again different estimate. So this number is slightly different than the previous slide that you saw. Previous slide, if you remember, we are close to around the 1980s was the time when we thought that it was we are kind of crossing that limit, but here it kind of leads to it kind of talking about different provisions that the different government agencies have come up in terms of trying to reduce the ecological footprint. Again, we'll spend some more time in the class talking about that, but very quickly if you look at what has happened, Silent Spring, which is one of the book I will highly recommend you to read if you have if you are interested in the environmental issues of this planet, of this globe. So this is Modern Environment Movement. So this Silent Spring book, like I do have it's sitting on my shelf. So you can you should read this book if you are interested in environmental issues of this particular planet to understand about that. Then we have this limits to growth. So identify global environmental sustainability problem. UNEP was established in 1970 something. UNEP is a global problem solving program. Then we have this Brundtland report which defined the sustainable development. So then we have the Rio Earth Summit happened, which looked at world's best hope for solving sustainability. 12-day conference, 35,000 activities, politician, business from 9,000 journalists. A lot of people came, and then it came with the Agenda 21 that UN proposed. It's a voluntary UN action plan. Then we had the Kyoto Protocol. That's a specific country goals. Then there was a Johannesburg Summit, which US did not attend, but only modest did not had much progress. Then there was a Stern review which suggested 1% of GDP tax, later raised to actually 2% to solve the environmental problem. Then we have Rio plus 20, no agreement was reached, but they did. That's why it is actually leading to it called Rio minus 20, and Paris Summit was there, which is like achieving voluntary pledge to limit temperature increase to 1.5% in terms of global impact and global climate change and global greenhouse impact. So again, you will see much more of these discussion happening in the class. There is a concept of this shrinking Earth as well, which basically tells you that as we are with a more and like as we had 7.9 hectares. Hectares of land per capita. So for one person on this planet, we had 7.91 hectares of land available in 1930s, and that number is going down to around 1.69 to now, and which is go further to 1.63 by 2050. So we have we need more and more Earth probably. So, if you look at the global footprint globally, if you look at global numbers, so China is number 1 in terms of different countries. Then we have US, India is at number 3 at around 7.5% contribution to the global footprint from India. Then there is this interesting concept of Earth Overshoot Days, which is marks the day when the humanity has exhausted nature's budget for that year. For rest of the year, we are maintaining our ecological deficit by drawing down local resources, stocks, and accumulating carbon dioxide in the atmosphere. We are operating in overshoot. So, we have one beautiful planet, but we are using the resources of 1.7 planet. So, we are using lots, we are getting into lot of ecological deficit, which you saw that earlier. We are in ecological debt, and this is the concept again. If you look at earlier, we were kind of close to if you are close to January 1st, that means you are good, because you are using whatever resources available for the entire year. We are using it. But as you go away from January 1st to December, October, November, August and July, we are basically using more and more resources. So, we are using up the resource. For example, if you look at on 2019 or 2018, which was right there, which was close to August 1st. So, that means that month of August, September, October, November and December. So, up to July, we have used up all the resources that the Mother Earth could have provided for that particular year. For the rest 5 months, we actually were borrowing, we were in ecological debt for 5 months. Because of this COVID pandemic, we saw certain depth, we saw the depth dip. So, now this number came to, I think that was August 22nd or so, rather than August 1st, it was August 22nd. So, we gained around 20 days because the activity was less. So, ecological footprint has gone down a little bit, but just only 22 days gain in this in terms of Earth Overshoot Day. So, not much. So, this is the country wise as well. If you can see, some countries here, they have a very small, they use up all the resource in February itself. Then there are some countries which is in the March, some in April, some May, and then there are some countries which are doing pretty good, like Indonesia, they goes up to December 18th, means they are only using 12-13 days of extra resources. So, otherwise they are pretty good. So, this is again we can talk more about that in the class. So, defining sustainability, you can look at googling sustainable development, you will find that Brundtland Commission report. So, as I said earlier, so sustainability means integration of environment, economy and society. So, there are different factors for society, different factors for economy, different factors from environment. So, we have to look at all together, wherever they meet together is your sustainable. Environment and society together is bearable, society and economy together is equitable, environment and economy together is viable, but where they meet together is that portion that you see over here, that is the sustainable. So, that is what our goal is, to go there. So, sustainability, you can find out the definition from the dictionary using a resource, so that the resource is not depleted or permanently damaged. Brundtland Commission, which was development which meets the need of the present without compromising the ability of the future to meet its own need. There is a whole concept of sustainable engineering. MIT in fact offers a program in sustainable engineering, where it is a design of human and industrial system to ensure that humankind's use of natural resources and cycles do not, it should be not here, do not lead to diminished quality of life due to either to losses in future economic opportunity or to adverse impact on social condition, human health and the environment. So, think about all these, and let us discuss more in the class when we talk about those. So, sustainability, making the life better for people and not worse, not covering earth in waste that never goes away, not using up all the stuff on the earth. So, that is what the sustainability is all about. Very simply, if you have to explain someone that making the life better for people, not worse, not covering earth in the waste that actually never goes away, not using up all the earth's stuff which is out there. So, this is if it is in terms of human needs, self-actualization, esteem, love and belonging, safety needs, psychological needs. So, this talks about all the different kind of needs and our fundamental human needs in terms of protection, affection, understanding, participation, leisure, identity, freedom and subsistence and all that. So, we'll in terms of how to have a proper balance of those in terms of our social inclusion, social practice. So, we need to have ecological balance, we need to go for low carbon, we need to have social inclusion, we need to have cultural vitality, democracy, non-violence, ecological, social and economic justice, good governance, all those factors comes when we actually talk about dimensions of sustainability in there. So, principle is of sustainability, if you talk about better environmental quality, economical things as well, promote social and intergovernmental equity, quality of life, incorporate disaster resilience. So, there are certain sustainable development matrices also out there, which is which we talk about 3P principle, like profit, planet and people. You may have heard about that earlier as well. 3P principle, where you have to look at the profit but you have to take care of the environment, the planet, and then also you have to have people has to be happy. That's more, but that is also very, very important. So, share knowledge, quality of life, accept responsibilities, take care of the human and nature coexistence, model nature, energy flow, look at the energy flow, eliminate waste, recognize interdependence, create value for all sections of the society. So, ultimately we have to go for what is known as the green economy, which the low carbon growth, resource efficiency and social inclusivity. That is what is known, that is what is sustainable development. So, that is the ultimate goal that your this in the coming few decades is where we will be looking at. We are looking at greener economy, which you may have, those of you who follow the news, who read some newspapers and articles and all that, you may have seen that it is more and more greener economy. So, greener economy is what we need all have to contribute to. So, with this I end this particular. So, this is what in week 1. So, very quickly as you know, it is a 2-hour lecture in the class. So, we have tried to cover those material in the video for maybe around I think what's 20, so around hour and a half, slightly more than hour and a half. So, we will discuss this more detail. So, please go over these videos before the class and then we will be talking about them will be in the form of more discussion. So, see you in the class, and again we will come up with more sets of videos for next topics. Thank you.